Okay, guys, we are picking up in lesson 8.6. We were working with, disk method yesterday, today's washer method, pretty much. And we'd already gone over the top of this page. Remember, basically, instead of doing pi r squared times the height, we're going to have to do big R minus little r. So the radius farther away minus the closer radius. So example 6 is where we are ready for. Find the volume of a solid generated when the region between the graphs of f of x and g of x over the interval 0 to 2 is revolved around the x-axis. Okay. Well, you want to start with the easier one? What's g of x look like? You guys can only see Ethan's face when he does that. Okay, so g of x equals x is that perfect diagonal line, right? F of x equals 1/2 plus x squared. What do you know?
It's a parabola.
Parabola?
Of path.
Of path. The fact that I think I was seeing double there. I got the same thing from Ethan and Jacob at the same time. So, okay, it's a parabola moved up half. Now, I'm not just going to go a little half. I'm going to kind of make it a bigger half. And I guess the one thing, if anything, you have to think about here is, does this parabola cross through that line y equals x? And it does not. I don't even know why I drew the left half of the parabola, actually. Can I take that off? I can. I don't even normally draw the left half of the parabola. You don't need the left half of the parabola. Because what interval did they tell us? It's only the interval 0 to 2, yes? So if we're going from, this is going to be 0, and then to wherever 2 is. Okay? So now, with that in mind, so if I look over here from 0 to 2, that means we're looking in that area right there, yes? And I don't know how this yellow will work, but we are revolving that piece right there, right? And we're revolving it around the x-axis. That yellow is probably not my best friend there, is it?
Well, I think it was cool.
Okay. So, we have everything we need in the picture? I think so. I mean, I guess I could label this as f of x, and this is g of x, so we have which is which, going from 0 to 2. I think we've got the important stuff. Now, what you've got to think about, let me grab a different color, is we've got big R. Where's our larger radius going? That's going to go from the f of x, right? So you've got big R, which is going to be this distance right here, because you're revolving around the x-axis. So it's a distance from there to there. And then that makes little r, that distance from there to there. And so do you see this? By doing the radius as the big R, that's finding that whole piece revolved. By doing the little r, we're going to be able to subtract that middle piece out that's going to be the hole, the washer, the hole in the washer. Okay? And this is, in case you want to write it in, this is a washer method. Okay? What you'll have to learn to do is to learn to look for, okay, is it disk method or washer method? Is there going to be a gap between the axis we're revolving around? Okay, guys. There we go. V equals. What do we start with? What'd you say, pi and what?
The integral.
The integral. Okay. We're revolving around the x-axis. So what are my values on the x-axis? 0 and 2. And they told us that interval, which makes it nice when they tell us. Now, remember when we're doing this, it's big R squared minus little r squared. So what's big R? That's f of x. So we're going to have the 1/2 plus x squared, quantity squared. And then we're going to subtract. And now we're going to do little r squared. What's little r? It's the g of x, and so that's just going to be x squared. And then, of course, times d of x, because d of x represents the height. One thing to watch out for. You know, I mentioned on AP multiple choice. They might throw in two of the same thing, one with a pi, one without a pi, yes? One other thing they'll do is they'll throw in its function squared, big R squared minus little r squared. They'll throw in where it's just big R minus little r and then squared afterwards. Realize that's not the same. Okay? So, okay. Do the math. Setup's the hardest part of these, isn't it? So, pi times the integral from 0 to 2. 1/2 plus x squared, quantity squared. What are we going to have to do here? We're going to have to FOIL. 1/2 times 1/2 is going to be 1/4. And then my outsides are going to be 1/2 x squared. My insides are going to be 1/2 x squared. 1/2 x squared plus 1/2 x squared is going to be x squared. And then the last, x squared times x squared is x to the 4th. And then minus this other x quantity squared is just x squared. What do you notice? X squared's canceled. There's always an advantage to cleaning up before you integrate, because you can integrate 4 terms here and do a lot of extra work. Which, is this the one that I started to do that without thinking? I think it is. But if we cancel the x squareds, now you're just integrating 2 terms, yes? So it's going to be pi. And I'm just going to go ahead and integrate. Integral of 1/4 is 1/4 x plus the integral of x to the 4th. 1/5 x to the 5th, evaluated from 0 to 2. Don't lose track of your pi. Let's see, 1/4 times x, or 1/4 times 2 is 2/4, 1/2, plus 2 to the 5th is 32, divided by 5. So 32/5. And then when you plug in 0, those would be zeros. So in order to add, I need a common denominator. Common denominator of 10. So 5/10 plus 64/10. (69 pi over 10).
When you multiply x squared times x squared, you're multiplying the powers, adding the powers.
The review is, let's see, I'm going to pick different numbers. X to the 3rd times x to the 2nd. Well, okay. Wait, where were we at? I'm trying to think. Okay, so x 3rd times x to the 2nd, if the bases are both there, you're adding. As opposed to x to the 3rd raised to the 2nd, then you're multiplying. Power raised to a power. So, yeah, since that was x to the 2nd times x to the 2nd, officially we added the exponents. Is that the reminder we needed? It's a very basic exponent rule that we always forget, right? Okay. Are you starting the next one without me? Maybe, maybe not. Find the volume of the solid formed by the region bounded by the graphs of y equals square root of x and y equals x squared about the y-axis. Okay. Can you visualize what those two graphs are and what they're doing? What's y equals square root of x? It's just y equals positive square root of x. It's just top of a sideways parabola. What's y equals x squared? That's a regular parabola. Now, you can go ahead and draw the whole parabola in if you want, but here's the deal. If I draw, and I'm going to take this off in a moment, if I draw that whole left side of the parabola in, is that going to affect anything? No, because it's right here. Since square root of x is only in the first quadrant, I'm only worrying about the first quadrant. Okay? Okay, so we're revolving about the y-axis this time. And what is it we're revolving about the y-axis? That little region between the graphs, right? I feel like I just drew a cob of corn cob. Corn in the husk. Sorry, had to share. Okay. Now, what do we still need to know? Yeah, we're going to have to know the interval, yes? Which axis are we going about? The y-axis, right? So I need y values. Well, we know our low interval, our low value. Our low value is going to be 0. What do we need here? What's that upper value going to be? 1. In other words, where do these graphs intersect? And they intersect at 1, 1, right? Because square root of 1 is 1 and x squared is 1. Now, specifically, which one do we need? I did already state that it's going to be the y values because we're revolving around y. Okay, I think we have everything we need to know. Well, I'll fill it in here in a moment. I didn't draw my big R and little r on, but I want you to tell me which is which before I draw them on and tell you. Okay, so what are we starting with here when we write this out? Got pi times the integral of 0 to 1, and those are y values, right? And then big R squared minus little r squared. What's big R? Oh, I guess we never solved each of these for x, did we? Okay, hold on here. Okay, so what did you say big R was?
X squared.
It's the x squared function, yes? Are you okay with this? Because we're going from the y-axis. Which graph is farther from the y-axis? This one right here, yes? And that is my, so big R is going to be the y equals x squared. Now what's the other catch with that I just realized I haven't done yet? We're integrating in terms of what? In terms of y. So I need to know what this is when it's x equals. And so when it's x equals, it's going to be x equals square root of y. So my big R is going to be square root of y. So it's going to be square root of y quantity squared minus, what's little r? Little r is the closer one, yes? So little r is the y equals square root of x equation. What is that when I put it in terms of y? X is y squared, right? So now it's going to be minus y squared squared times dy. And from here, it's just about practicing the math, right? So pi times the integral from 0 to 1 of y minus y to the fourth dy. Our last one was different. Okay, integral of y, let's see, we've got the pi. Then it's going to be 1/2 y squared minus 1/5 y to the fifth, evaluated from 0 to 1. Pi times, when I put the 1 in, 1/2 minus 1/5. The zeros are going to be nothing. It's going to be pi times 1/2 minus 1/5, 5/10 minus 2/10. So I'm going to have 3 pi over 10. Okay. Example 8. Love it when they already give us a picture. Find the volume of the solid generated by rotating the region bound by y equals x minus 1 squared plus 2 and y equals x and x equals 0 about the x-axis. I feel like technically they didn't give us they never told us this too. Wait, that writing doesn't make sense.
Should it say x equals 2?
I think it should. I mean, because we're just kind of assuming that. Or it should say x equals 0 and x equals 2. I really feel like technically they never told us that, but the picture's showing us that, isn't it? Okay, that you're stopping here. And it's rotating about the x-axis. Now, basically we're going to work the problem. It's just broken into pieces here. But let me ask, disk method or washer method? Washer method? Because there's going to be a hole here, right? Or almost a hole. I guess technically that won't ever be a hole right there, but very close to it. So this is a washer method. I guess I never asked that question last time. I'm guilty of not remembering to ask that. So now, when they say write the area of a single slice, okay, so area is what we're integrating. So area is the area of that cylinder, that disc, or in this case, that washer, right? So basically, area is everything but the integral, if you want to go there. Now, so for area, what do we need? We're going to need, of course, a pi, right? What else do we need? If we're just thinking to do area of that single slice, we're going to be doing the pi r squared, right? So we've got the pi. What are my r's? What's big R? Farther one away, yes, as opposed to little r. Now, with that in mind, set up this equation. It's going to be pi, because we're trying to find the area of that washer, so to speak, right? Big R squared, which is going to be, let's see, what am I have to do? I'm going to have to do parentheses, and then parentheses, x minus 1 squared plus 2, and I'm going to need the second set of parentheses, minus, then it's little r squared, which is just x squared, And keep in mind, I'm working in terms of x's because it's about the x-axis, right? And then officially, since we're talking, well, I would say the area is just that right there. I know when I checked the answer key, they went ahead and put the dx on here, but to me, that's part of the volume. Now, integral for finding the volume of the solid. What are we basically going to do? Take the area and put it in an integral. So if we take the area and put it in the integral, volume is pi times the integral. And I'm going to put the whole thing in a big bracket. Parenthesis for the first function, parenthesis for x minus 1, quantity squared, plus 2, in the parenthesis for the first function, and square it, minus x squared. And I'm ending the bracket, which is, that's all my big R squared minus little r squared. And then to make it volume, we need times the height, and so that is dx.
What about your limits on
That's what I was going to come back to. What are my limits?
0 to 2?
0 to 2 because we're talking in terms of x. Yeah, I realized at the time, I was like, I'll come back to them. C. Find the volume of the solid 2 3 decimal places. So what are we doing? We're using our calculator. Good luck getting all the parentheses right.
Mr. Sargent, I will give them.
And that's your hint right there. When it says to 3 decimal places, you know that they're just looking for a calculator answer. Are we getting something? I guess I only say good luck because I struggled with this one because I have 2 different answer keys that I look at. And the first answer key I was wrong compared to the first answer key. I was like, oh no. Retrying everything. Then I went to a different answer key. I was like, oh, okay. There's one of them that's wrong. Okay, what'd you guys get?
2.
Did you just say 2?
Yeah.
I have a problem with that answer.
Can I take that?
I figured there's probably something wrong.
So if he says 2, can I move that 2 to the tens place, then put a 6, and then 0.389?
I like that answer better.
What did I do? That's fine.
So if you have an answer of 8 something, then you forgot times pi probably. But I don't know if you have 2. I don't know what
I
you
have
Jake, is your calculator in the right mode?
You didn't square after that function right there. You never squared big R.
Oh yeah, I knew that.
You see that? Oh, of course you did.
Yeah, I was
So
just
you-
testing you to make sure.
Of course. Well, I have, a good test there. There you go. 8.4 is, okay, yeah.
Yeah.
Okay. So Jacob will tell you the integral without multiplying by pi is 8.4. Just so you know. Okay. One more.
Yes.
Number 9. A solid plastic sphere of radius 5 inches will have a hole bored out of the center with a radius of 3 inches. What is the volume of the resulting plastic sphere? Now, this one was a little bit hard for me to visualize at first. Me personally. This picture is in my notes, but I didn't really get it until I saw it in here in the color or whatever, but so sphere, right? A ball, but there's a whole board in the center. So right here, it's like you could take a pencil and stick it through the center or something, right? It's hollow in the center. So we're trying to, they didn't give us, I mean, the first thing it asked for here is an equation. They didn't tell us what shape this is other than a sphere or what type of equation or how we're doing anything like this. Okay? Thank you. So, with that in mind, we have to come up with that stuff. So, a plastic sphere, what is it we're going to find the area of that we're going to revolve that's going to create our plastic sphere?
Circle.
A circle, yes? Because you take a circle, you revolve it, that's going to create a sphere. Now, I haven't touched the whole idea of the hole in the middle, right? But just the idea that if you're taking, now, I'm not going to leave this whole thing here, but if you take that, I'm not leaving it, and you revolve that whole thing, right? It becomes three-dimensional, it becomes a sphere. Now, do I need this whole thing up here? No, I really only need the top half. As I said, this is where I'm like, I'm not leaving it. Now, I don't even know if I want, let's see. There we go. We're going to go with that. We're going to call it good enough here, okay? Now, what is the equation of this circle? Now, that's the area of the circle.
X squared plus y squared equals 25.
Does this sound familiar? X squared plus y squared equals r squared is what we officially say, right? But this is area of a circle, or excuse me, equation of a circle, center at the origin with a radius of 5, yes? Now, if you want to go ahead and think about this, I guess it doesn't say what axis we're revolving around, does it?
We can choose
We can choose. What is my picture kind of chosen?
X.
My picture says we're revolving around the x-axis. You guys okay with that?
I'm choosing.
Okay. So that means I'm going to have this equation solved for y in terms of x, right? What is this equation if I say it's y equals? 25 minus x squared, the square root of it. Officially, it's plus or minus the square root of it, but we're only looking at the top half of the circle, right? Okay. We need a hole bored out of the center. It has a radius of 3 inches. So what's the other piece we're going to have to think about here? What did you say, Jacob? A line. Yes? We're going to need a line. Made that a little, well, doesn't really matter, but what level do I need to make that line at?
3.
At 3. Because this hole has a radius of 3. The sphere has a radius of 5. Are you seeing this? And technically these are 5s here, right? Because everything goes out 5. So the other equation, what is that equation for that line?
Y equals 3.
That is y equals 3, yes? Just going to go ahead and write it down. Okay. Interval. What is the piece that we are revolving? It's that piece there, yes? So thoughts on the interval? Unfortunately, no. I totally agree with you. I totally went wrong on this
Are
one.
we gonna say like 0 to 5 and multiply that by 2?
You go by where the feet.
Does
Oh,
the
wait.
section we're revolving
Oh shoot.
go all the way out to 5?
Oh, it's where it meets.
Don't worry, I fell for it too. Because that makes you feel any better. So what do we need to know? We need to know what these points are, yes? So I'm looking for where my circle has a y value of 3, basically, yes? Because I know since this is y of 3, I know it's going to be something comma 3. What is that y value of 3? Can you do it mentally? Are you working? Should be 4. Because here's what my brain says. 25 minus 4 squared. So 25 minus 16 is 9. Square root of 9 is 3. Right? So this is going to be, these intersection points are going to be at 4, 3, and at negative 4, 3. And if your brain said, whoa, no, Mrs. Sargent, I don't like that, then take this equation right here and set it equal to 3. That's all I did. I just solved it in my head. Right? If you set this equal to this, where do they intersect? Okay? And so you end up with them intersecting at officially plus or minus 4. So my interval is going to be from negative 4 to 4. Okay. You ready to do this? Officially, all it asks for is the integral, doesn't it? I have an answer written down on my page, but yes.
Do we also do 0?
And
Multiply by 2.
yes.
Yeah.
Yeah. And here's what I'm going to say is, this one's showing as a calculator active problem, yes? Is it a big deal to put negative 4 to 4 in your calculator? No. If I'm doing this one by hand, I definitely like the idea of 2 times the quantity or the interval 0 to 4. Okay, that's my point I'm going to make there. So, but yes, both, this is definitely symmetric. I'm good with that. Okay. Integral, v equals, what am I starting with? Pi times the integral. I'll write it both ways. So I'm going to start with the official way of negative 4 to 4. And then what? We never talked about it. What's big R and little r? Big R, little r, yes? Are you seeing the big R, little r okay? I don't feel like these have been too difficult of examples. So, big R is going to be the square root of 25 minus x squared, quantity squared, minus, what am I using for little r? Just 3, because it's y equals 3. So if it's y equals in terms of x, so 3 squared, and then times dx. If you liked Jacob's idea, and you want to put 2 out front, and then go from the integral from 0 to 4, that is perfectly fine as well. Okay. Either way, it doesn't say answer on here, but I have an answer written down, so. Do we get one?
Two. 6.
8.
Point
0.
8. Units. Cubed.
I say units.
Inches.
I say if you're gonna throw in, do we have? Oh, we do.
Ooh, inches. Let's see that.
Inches cubed, if you want to be specific. Why is it cubed? Because we are talking volume.
Sorry, you're supposed to say cube.
Sorry.
I said
Inches?
inches.
Oh. Well, you know, it's fine.
Okay, guys,
Correct.
Oh, yeah.
give the homework a try.